Good evening, everyone. We are going to start within 2 to 3 minutes. Let others also join, and then we will start with the presentation. Okay, so I think up to the now we can start with the presentation session. Those who will join lately, I will take their presentation on behalf of that. So, how many of you haven't given the presentation? I guess only Arva haven't given it yet because Mansi and Pranav has already given their presentation on the previous session. So, Arva, are you able to present today? Have you completed the projects? Hello, Arva. Am I audible to you? Guys, am I audible?
Yes, sir.
Okay. So, hey, Arva, are you there? Okay, so we will wait for some time. I guess she is not on the call right now. I might be there an issue with
All
her.
right.
Okay, so Vivek, have you completed your project? If you want to present, you can also present. Hello, Arva. Am I audible to you? I think. Okay, so let me just check that if other students will join, then I will start with the presentation. Hello, Divya. Have you completed your project? Okay, Divya. So I think we can start with you. Just give me 2 minutes and then we will start. Okay, so Divya, are you ready with your presentation? I think we can start with you because a maximum of them has already presented on Wednesday. So first you have to present, then Arva, second you have to present. Okay.
Okay, sir. Sir, is my voice audible clearly?
Yeah, yeah, your voice is coming. Just share your screen.
Okay, sir. Just a minute. Is my screen visible, sir?
Yes, it is visible. So just share your project and let us know what you have created and all the best.
Yes, sir. So this is my project, sir. Segmenting credit card users. So in many credit card companies, we have many types of users. So manually, we segment the users is very difficult. For that, I have analyzed their different spending habits and financial behavior. And based on that behavior, using machine learning techniques, I have divided them into high spenders, low usage customers, risk-prone users like that. For that, I have imported libraries like pandas, which I have used for analyzing the data set and loading the data set. NumPy for numerical calculations, Matplotlib and Seaborn for visualizations, and this sklearn is used for pre-processing step like this standard scalar is used for scaling, PCA is used for principal component analysis, and k-means for clustering, and Silhouette score like that I have used. Then I have connected my
Okay.
Google Drive to the Google Colab, and I have loaded the data set into it, and I have displayed the column names. Here we can see. Then I have displayed the first 5 rows of the data set to make sure that how it looks. So here we can see some column names like customer ID, bank balance, and we can see some columns which we'll be seeing below. Then we have data set rows and column count. Using save function, I have displayed the number of rows and number of columns. Here we can see number of rows are 8,950 and number of columns are 18. Then using dot info function, I have displayed the information about the data set. Here we can see the column names, whether there are any null values and their count and their data type. Then for understanding the variables more clearly, I have displayed their column names with their data type and data description. Using describe function, I have calculated their count, mean, standard deviation on all those on the numerical columns. And about the feature description, I have here described about the every variable. What does it mean? Like here we can see. Then in the data processing step, I have handled the missing values. For categorical columns, I replace the missing values with the most repeated value, that is the mode. And for numerical columns, I have replaced with the median value. So you can see here before handling the missing values, uh, minimum payments have 313 null values and credit limit also has one missing value. So after handling, you can see that there are no missing values. Then for handling duplicates, first I have checked for duplicates using duplicated dot duplicates. But if in case there are any duplicates, I have dropped the duplicates. Then for checking the outliers, I have used the box plot. Uh, Above this box, we can see the dots, which means they are outliers extreme values, which may create a problem during analysis. For that, I have used IQR method and replaced the outliers with the median. And then for understanding the relationship between the variables, I have used the correlation heat map. Like here we can see red or dark red indicates that there is a strong relationship between the variables. Blue and light blue mention that there are negative opposite relation between the variables, and some other colors represent that there is no relationship between the variables. And then is the principal component analysis. Like I have before in the data set, we have seen the 18 columns. So using PCA, I have reduced into two main features, and I have scaled it like this using this fit transform function, and I have displayed like this. Then I have when we combine those 18 features into only two features, here we can see that how first component analyzes only 25% and second component 15%. Like here you can see, then I have used the PCA projection. So this dense part indicates that there is some clustering possible and some other points, like here each point represents a customer, and PCA 1 and PCA 2 almost take 47.6% of their total variance. This is sufficient for visualization, and then we go for uh, uh, k-means. For that, I have used first to find how many number of clusters are possible. For that, I have used the elbow method. Like here in the graph, we can see that where there is a sharp bend, we can see that that many number of clusters we can see. As the number of errors increases, as the number of errors increases, the cluster decreases. Like here we can see at 2 or 3, there is a sharp bend in the graph. So it suggests that we can form 2 to 3 clusters. Then since inward score, we can see that. So where there is a higher score, at that point we can find the clusters. So here we can see at 2 to 3 and 4 we can find some cluster. So satisfying that both, I have used k equals to 4 and divided the cluster into
Okay.
divided the customers into 4 clusters, and I have given the label like 0, 1, 2, 3, and so when I have displayed that here, I'll be getting an extra column like you can see here, like, we'll getting extra column like cluster, mentioning
If
that
your
which
voice is breaking a bit, can you please check once?
now is it clear, sir?
Yeah, better than before.
Okay, sir. So this cluster column mentions that which customer belongs to which cluster. This number does not mean anything directly, but it says that they belong to some particular cluster that have some specific behavior. Then for visualizing the clusters, I have used this and visualize that scale data. And like here we can see.
Okay.
So there is a slight overlapping in the clusters, but still we can see. Then for analyzing the clusters, I have displayed the cluster profile, and here we can see that it have performed all mean values of the every column, and then we can see the cluster interpretation. As here we can see, cluster 0 means high standards, cluster 1 means low usage customers, cluster 2 means frequent users, cluster 3 means risk prone customers. And for visualizing cluster profiles, I have considered some key features and displayed their graph so that we can understand based on how they are see. Like here we can see cluster 1 has high balance, indicating that maybe they are low usage customers, and we can see in average purchases, uh, cluster 1 has very low value. So like that,
Yes.
by comparing these graphs, we can understand that how they got that cluster meaning, and that's
Okay.
it.
Okay, okay. They were very well presented and well explained. So great work at your end. Keep going like this. You are doing good. Okay. So now, Arva, are you ready with your presentation? Hello, Arva. Yeah. Just unmute yourself. Your screen is loading.
Okay, good evening, everyone. Just a moment. Okay,
Yes, now you
first
can
of all,
continue.
yeah, today I'm going to present my project called Athlete Performance Tracker. It's a backend REST API built with Node.js Express and MongoDB. The idea is simple. Coaches and or teams can use this system to add athletes, log their match performance, and view their overall stats like total goals and assists. I walk you through each file in the project and explain what it does. First of all, we start with this file, which is .env. We have two lines here. The first line, which is Mongo URI. This is the address of our local Mongo database. I didn't connect it to Atlas, so I did everything locally. It tells our app where to find the database on the computer. The database name is Atlas Tracker. Now,
Okay.
also the second line is the port, which is equal to 3000. That's for the first file. Now let's move to the packages or package.json. Um, I didn't create this file. It was automatically created when I started the project. Think of it like an ID card for our project. It contains the project name, the version, and most importantly, the list of the packages that we are using here. The packages Express for building the API, Mongo's for connecting the database, which is MongoDB, and also dev dot net env for reading our settings file. And then we also have a script section section here. The dev script runs on our server using Nodman, which automatically restarts the server every time we save changes, so we don't have to restart it manually every time. Yeah, that's it. Now let's go to the config.
Okay.
Did it? Okay, the config. So I have a previous experience with Django and Laravel, so I tried it to make the files somehow similar to the MCV model, which is I put the config files in a folder, then the models in a folder, and the routes in another folder. So that's like I felt is more familiar and easy for me to work with.
Okay.
At the top, we bring Mongo's. That's the package that lets us to talk to the MongoDB in a simple way. Then we created a function called connect to DB. Inside this function, we first read the database address, our .env file using process.env mongo URI. Then we connect dot catch here. Dot then names if the connection works, print success message. Don't catch means if something goes wrong, we print the error message so we know what happened. The last line, it's very simple, which is we express this module. Now let's go to the modules that we created, and basically those refers to how we created them in the database. Think of it like registration form. Every applet we added must follow this exact structure. We use something called a schema that's related, or let's say that's the blueprint that tells MongoDB what fields to expect and what type of each data should have. So we have name and must be string. We have an age must be number, position must be string, and team must be string. All that kind of stuff. Now we did also the same for
Okay.
match. We created a model. It has the applet, which we connected to the applet object ID, and we have opponent, match date, goals, assets, minutes played, and
Yes.
very simple. Now let's
Okay.
go to the routes. Just a moment. Yeah. At the top, we bring Express and it creates something called a router. And when someone sends an applet, first of all, before that, it's like just I understand
Answer.
it like a traffic. Just okay.
Uh,
Think of the router like a traffic controller. For the people that doesn't know about it, it decides what to do based on the type of the request. We have three routers here. We started with pods and a slash, and this is used to add a new applet. When someone sends an applet data like name, age, position, team, we read the data from Rick dot body and then team, position, age, and all that kind of stuff. The second route here is get. This fetches all athletes from the database using athlete find, and yeah, that's it. That's what it pretty do here. And then the last one, which is get by ID, and here we copy the ID of the specific athlete that we are looking for, and we get the request or the athlete information, the athlete. Now here the match route. It contains first of all pass, which we do simple request slash. This adds the new match record before saving. We first check if the athlete actually exists in the database. If not, we stop. Just a moment. Okay, I'm sorry.
no problem.
So yeah, when we restart, the third router is the most interesting, which is get request slash matches slash ID stats. This is our KPI route. KPIs mean key performance indicators. Just a moment. Yep. Yeah. Stats, which is key performance, like total goals, assets, minutes played, and this features all the matches that are played to the specific athlete, and it gives us all the information about this athlete. And then server.js. And
Okay.
okay, just a moment. Okay, so the first thing we do all called .env config. This loads our data .env file so we can read the port and Mongo URI values. Then we created Express app. We added one important line, which is app use express.json. This tells Express to understand the JSON data that comes in form of requests. Without this line, we wouldn't be able to read the data people send. Then call uh, ConnectDB. This runs the function from our database JSON file and connects to the MongoDB. We have a simple test route slash just to confirm the server is running when we open it in the browser. And I've run a couple of tests on Postman. So just a moment, I'm going to share with you. Okay, I hope
Uh,
so. Yeah. Okay, we did the first thing, which is get localhost, and here it sends us as a message Atlas Performance Tracker API is running. When we said the
okay.
get function and method or get method and this
Yeah.
link. Now the second thing, which is we did post method, and this post method we sent it to the slash athletes, and we sent a content in the body, and we did a name of a player and his age, position, and team, which is Liverpool, And then we sent and get the message athlete added successfully and the information about the athlete. And one of the important things, which is this ID that we're going to use later on to call it, no, just not, yeah. Now get athletes, which we get all the athletes in the database. And since I've seen the same information about same athlete, so we got two, but they have like pretty the same information except the ID, which is different. Now,
Okay.
okay, now the athletes slash the athlete ID, which now it give me like the specific athlete that we want, which is this information that we want. Okay, past moments, yeah. Now past matches, we added a match and the same match with the same data, which is the same body. I've sent it again. I have two matches in total, but with the same information. And now when we go this, get and then the same ID of the match. We've got the
Yes.
information about the match and everything. So all the matches. And then the last but not least, just a moment, yeah, the stats. We send the ID of the player in the stats, and here we got it. The player has total matches two, total goals two, and two assets two. So that's all.
Okay, okay. Great work, Arva. And that's a good practice that you have created .env file. Even there was only a MongoDB URL and the port number, and that's good because what happens that when we push the code into GitHub, so these .env files keep our credentials secure. So that is very important uh, in order to safety purposes. So great work. Nice. Keep it up. Now, Yatham, have you completed your project? Yatham Tejeswar Reddy. Hello, Yatham, are you there? Okay, so let me just see that how many of you have presented. Divya has presented. Lalit has also given the presentation on Wednesday. Mansi has given it. Pranav has given it. Yatham is not responding. Arva has already given it. Okay, so I guess no one is leave for the presentation, right? Okay, Vivek, yes, you can start.
Good evening, everyone. My name is Vivek Kumar Yadav. Uh, I have developed a backend project named Product API using Java and Spring Boot.
Okay. Uh, Vivek, just also share your screen. Yeah, it is loading. Yes.
Just give me 1 minute.
Yes, yes, take your time.
Developed a backend project named Product API using Java and Spring Boot. This is a RESTful API that perform CRUD operation on products.
Okay.
The project follow a layered architecture including controller, service, repository, and model. This is my base package uh, com.example.product API where all components are organized. Uh,
Okay.
this is the controller. 1 minute.
Yes, yes, take your time.
This is the controller layer which handle HTTP request.
Okay.
I used REST controller which return JSON response, request mapping, define the base URL, get mapping, post, put, and delete mapping are used for CRUD operations. Uh, path variable are used to get value from URL, and request body used to accept JSON input.
Okay.
Second one is service layer. This layer contains business logic. I used service annotation, so Spring manage this class. It helps to keep controller clean and improve maintainability.
Yes.
Next is repository layer. This layer interact with database. It extend JPA repository, which provide built-in method like save, find all, and delete by ID. Uh, Next is model layer. This is the entity class which represent a database table.
Okay. Good.
Entity mark it as a table. ID annotation is the primary key, and generate value, auto generate ID.
Okay.
Next one is exception handling. This package is used for global exception handling using controller advice and exception handler.
Yes.
Next one is application property. This file is used for contribute configuration like database connection and server port.
Okay.
Technology used are Java, Spring Boot, Spring Data, JP, MySQL, Maven, and Postman.
Okay.
Next one.
Yes. Yes. Take your time.
Now I running my Spring Boot application.
Okay.
Spring Boot start embedded Tomcat server uh, internally. All component like controller, service, and repository are initialized. Now the application has started successfully on port 8080. This means the backend server is ready to accept HTTP request.
Yes.
Since this is a backend project without a front end, I'm using Postman to test API.
Okay.
Mm. I'm sending data in JSON format using request body. Uh,
Okay. It's
uh,
working.
after click send, the response confirm that the product is successfully created.
Okay. Good.
Uh, this is a get request to fetch all product. Uh, After click send, here we can see all product in JSON format.
Yes.
In Postman, I am testing all HTTP method like get post, verifying response status code and JSON output.
Okay.
The request flow is client to controller to service to repository to database uh, to response back to client. This project helped me understand the REST API development, Spring Boot architecture, and backend design. Uh, in
O-
future, I plan to add JWT authentication, validation, and integrate it with React frontend.
Okay, great.
Thank you. Thank you, sir.
Okay, okay. Well done, Vivek. Good explanation. Also, that it is good that you are clear with the future goals, that how you can improve it more. So that's really appreciable. So great work at your end. Keep going like this.
Thank you, sir.
Okay. So I think now everyone has given the presentation. If still anyone wants to give the presentation, they can raise their hand. But only Yatham Tejeswar, I guess, has not presented. Okay, so Yatham, have you completed your project?
Yes, sir, I have completed. I'll just 2 minutes. I'll be sharing the
Oh,
screen and I'll start
okay,
presentation.
okay, take your time. Okay.
Hello, sir.
Yes,
Hello.
now your screen is visible. Also, you are
Yeah.
audible. So just go ahead with the presentation.
Okay, sir, I'll start with my presentation. Sir,
Okay.
going ahead with the presentation, first I'll start running the code.
Okay.
As the code is completely like I have created one application also for this. So this project comes under data analytics project, and this includes like Excel everything.
Okay.
So I have created one complete folder for this. So hope you can see here, like these are the files that it has. Mm,
Okay.
Let me run like all this all has that Python code. So this run all code will be having the final main function in this. So if I all these are working, if all these are working, then only this run all function also will work. So first I'll
Okay.
start with working of the project once again. So here the pipeline will start like with the system architecture. And like
Okay.
first we have to set up the database so you can able to see whatever the records that we have in the data set. I will
Yes.
show the data set as well. So first we have
Okay.
to set the data set database. So first we have to convert the CSV into a structured SQL for the querying. So basically we'll be having so first I have said that like whatever the database that we have, that's why we used pandas and also in this. Pandas, it's basically for whatever the CSV file that we have here. This is the data set. So we have to convert this into the database. That's why we are using here Pandas, as well as this. This is SQLite 3 version, which is for embedded database for data storage as well. Now I'll start with the setup has been completed. Now I'll start with the main application. So instead of predicting the model everything line by line, I have created one complete application so that it will be become easier. So one second, I'll show that
Okay.
too. Created one app for this. So this will start working. This is the app.
Okay. Looking
This
good.
is smart crop yield prediction. So here it's basically like whatever this will be the inputs here, like farm inputs, like what crop you're using,
Okay.
the farmer has cultivating, and here what the location and what is the season, and these are the parameters like on which year you wanted to predict, and this is like how for how many acres, how much production that you're getting, and this will be in millimeters for the rainfall, and how many kgs of per hectare you're using the fertilizers as well as the pesticides. Let's say
Great.
I'm here, I'm thinking, I'm giving the, let's say coconut, and coconut is rich in Kerala, so that I'll check for Kerala. Then here I'm putting it as, okay, summer season I'll put. Planning year, I'll put it as 2025. Now farm hectares, let it be 1200. Now I'll keep to 2000, okay, some 2400. Now, okay, 200, okay. Now this pesticides also have increased. Now, whatever the yield will be getting, you can able to see this.
Okay.
So here you will be getting the output, like how much tons of per hectare you will be getting for coconut in, especially in season, in summer season in Kerala. So these
Good.
are the farm performance analysis, like how much you are estimating, whatever
Okay.
the yield improvements that you are getting. Now here, if you can able to see all the trends that you can able to see from the past few years, how much yield you're
Yes.
getting. So based on this, the farmer can able to know how much, like when it goes to peak, when it goes down. So which season will be better for this, for different states also it might differ. So that you can able to check like whatever the states at which how many tons you're getting in that particular area, because based on the environment also the production, the cultivation or the harvesting might be differs. Then you can able to compare the crops also, like on which season, on which crop how much yield you're getting. This is the metrics. Then you can go to impact analysis also, you can able to see this dot plot. You can able to see the legend where the which crop is better in which rainfall. Fertilizers heat map also will be plotted here. So complete complete thing you can able to see. If you wanted to see it in line by line also, you can able to run here. So one second. Okay. So if you wanted to see how this prediction goes, okay, you can able one second. The prediction also press Python. So here you can able to select like whatever the thing that we had done in the application, we can do it in this model also. Just I have used a Flask for a lightweight component to build a mini website, so that becomes easier and looks so charming. So
Okay.
let's say here cardamom I take, and then tell West Bengal, not West Bengal, like some other Jharkhand, let's say Jharkhand. But it has still Rabi crop of 2025. 1200. So, 1800. Then fertilizers, I'll be giving input. This I'll be giving 20. So this you'll be getting the production in terms of tons.
Okay. Perfect.
And here, see, I have created this application as well as this. You can this or this you can use. Both you'll be getting the complete inputs and outputs here. So
Okay.
basically, first, I have different files I have shown here. In this notepad, I can able to show the code once again. I don't know, this notepad is not working because of. I have opened one .apk file. Because of that, it's taking some time more. One second. Second. Uh, I have used pandas also here, pandas and also SQLite for managing the SQL database.
Okay.
Then moving ahead, I can able to show the code also, but I don't know, it's not opening. Might take a while. Okay, I'll open like this only. Right. You can see the code here. This is
Yeah.
the first code. This code is basically to convert data set what we are having. To read the data set, we are using pandas also for the to convert the data set to keep it in to read the file from the database. We are using here pandas. You can
Okay.
able to see what technologies that we are using, how we are converting the yield into the numerical values. And first of all, we have to remove the whatever the duplicate values, everything that data cleaning process also have done here. Then here these are the queries that you can able to see for doing this aggregate and group by functions. Um, then this cursor is basically to when you're doing any kind of querying process or retrieving the data from the database, you will be using cursor. Then hereafter, then we'll be having the main model and the prediction model, how the prediction model also works. Hope you can see here how we are calculating the median values, all these statistical measures that we can able to see here. Here basically we are training the model using a regression. We are using simple linear regression here. So based on there will be one independent variable and dependent variable, as we have multiple fields in the data set. So one becomes the main, this will be your output variable, and these all are your input variables. So based on that, if you give any input, this should be predicted. So this yield should be
Okay.
predicted. So this yield will be your dependent variable. All these are independent variables. This is an dependent variable. This will be dependent on all this. This shows the linear regression and how we are saving the model. This basically goes how the training model goes and how the testing will happen. and this model will be saved, and this function will be stored here, and this main function will be called in this run all function.
Okay.
So whenever this only I have converted this into the application. You can see this application code. So this code is basically for making the website and the small application that I have shown here.
Okay. The UI.
This one,
Okay.
this one, for making
Yes.
the smart crop yield prediction.
Okay.
Any doubts here?
No, no. First of all, very good project, Yatam. I can say one of the best up to now. So great work. And also you have explained it good. So keep continuing like this. Okay. And now I expect more, like upcoming projects will be more like this only, right? So
Yeah, yeah,
great
yeah.
work.
No,
Okay.
actually, like when you are doing any kind of projects, so first, if you can able to all the time, you cannot able to keep on giving the inputs. So it takes like we have to train the model whenever you are giving the command in the command prompt. So
Yep.
that becomes a delay in. If you create a web application so that you can able to give the input here and the output will be immediate to you.
Yes.
So that becomes good. So
Yeah.
that's why I have planned like this.
Okay. Okay. No, this is looking quite well. And as the data analytics student, I know that while creating UI, it takes a lot of efforts also. Like you have to be,
Yeah, yeah, yeah.
yeah, aware about Flask as well. So that's great.
Yes.
Good. Okay. So I think now everyone has presented their project. So well done, guys. All of you have given the good presentation this week. And that's what I am seeing the improvement in all of you. That from week one, there is a lot of improvement within your confidence as well as your explanations regarding the project. So great work, all of you. Thank you so much. Now we can continue with other week presentations from the upcoming week. So all the best for upcoming week projects. So have a nice day. Now you can leave the session. Thank you so much for joining.